Nanjar, good evening. Hello, am I audible? Nanjar. Nanjar, am I audible? Okay. Nanjar, are you there? Oh, sorry. I think I have made you. Sorry. I have made Bhumi as the host. Okay, fine. Achha. Just a minute. Now, yes, Nanjar. Now you can.
Yes. Good
Sorry.
evening, sir.
I have made Bhumi as the host. It's okay.
Oh,
No,
अच्छा,
no problem. So I think we'll wait for another 3 to 4 minutes. Let's
yes,
wait.
sir.
Then
Then
we'll.
we'll start.
So, Nayan sir, tomorrow onwards, there will be no class for the next 5 days.
Okay,
Hmm.
sir.
You also try to join.
I'll join that session.
Yes. All the session, 3 sessions are there. In case
Hmm.
if you are not able to join, you can that videos are going to be uploaded. You can watch. So that I also want that you can start some work on the speech also.
Yes, sir.
That the good resource persons are there. We should learn something from them. So, Mahadev Prasan, who is the means pioneer in that speech processing field, he is going to join the inauguration session, but he is not going to take the first session. He is going to take the session
When second session
on 11th. He is going to take the session.
on 11. Okay.
Dr. Madhusudan Singh is going to take the first session. Then followed by the name some Sharma from IIT Guwahati. He is going to take the session, second session, like that. That schedule I am going to share with you all. I'll share a link, WhatsApp link. You just try to add yourself in that faculty group so that all
Hmm.
the information will be shared.
Okay, sir.
But around 71 faculties are joined.
Sir,
Along with some students are there, around 200 students also have joined. And many of I have
please
asked.
send me that one so that I
Yes,
can.
I'll send you in WhatsApp group today only.
Okay.
So wait for another 2 3 minutes, then we start.
Yes, sir. Is it visible?
Yes, yes, sir.
Okay. So, good evening, students. So, today we'll start the last three parts from where we have left in the last class. So, in the last class, we have discussed the first three parts of this ML pipeline. One is data acquisition. Second is very important is pre-processing, followed by feature engineering. Sometimes feature engineering is required, or sometimes it may not be required, but pre-processing is very much essential. After this, the last three part today we'll discuss. Among these, the first two are very important. One is model building or modeling. Second one is evaluation. Modeling, what we'll do, we'll model, try to train a machine learning model which will use the pre-processed and cleaned data. Once we create a model, then we evaluate whether that model is performing well or not. And once we are satisfied that the model is good, then we'll use it for prediction or in any real world deployment. Start modeling. So before modeling, once the data is properly curated or cleaned or pre-processed, next, before going to create any model or train any model, what we'll do, we'll divide the data set into two subsets. One is training set. This is training set. Another one is that we need test set. So the training set is basically used to train the model, and the test set is used to evaluate the model after the training. The question is why we need to divide them, because you see, when we got a problem, the for solving that problem, we have decided that we'll use a ML model, because there is no such programming approach, traditional programming approach that will be used to solve it. So we have decided for that we have collected the data and created a data set. Then we pre-process it and clean it. Now we have a cleaned data set. Now when you have a clean data set, if you use all the data of that data set to train a model, what will happen? The model, once it is trained, yes, you can do it, but how will test that whether that model is performing well on similar kind of data or not? So again, what you did, again you need to collect some other data, and again you will have to test it. But instead of doing that, the general practice is, once you got a data set, you have cleaned it, then you divide the data set into two parts. One will be used for training purpose, and that means most of the data will be used for training purpose, and a small subset of the data which will be used for testing purpose. So the training purpose means generally the ratio is 70-30 or 80-20, mostly 80-20. That depends. So means sufficient number of data must be there for training, and some reasonable amount of data is required for testing. So once we do that, then we'll go for model training. So today I will discuss two basic machine learning modeling techniques, and rest you can refer from different sources. So question is, what is model training? This is the third step. Model training means the model will learn from the patterns from the training data, because we know that there is an inherent pattern available inside the data set which we are unable to discover by the traditional programming approach. So what we'll do, we'll use existing training algorithms or ML algorithms. We will use these algorithms to train a model on that data set. Okay, and what it is doing, during training, it will try to find out a relationship or a function between the features, all the features which are available in the data set, and the target Y or label Y. So it's doing one thing, only try to figure out a function from X to Y. And the goal here, how will do that? The goal is basically using some prediction error. So that means once you train a model, that model you will use the training data to predict to get the answers or output. If that output is not actual, is not equal to the actual output, then what will do? Again, if there is an error, you calculate the error, model that error as a loss function or cost function, then you want to optimize that. That we'll see during the course of discussion. So there are different ML models available or algorithms available. One is KNN, logistic regression, support vector machine or SVM, then naive-based classifier, decision tree, random forest, XGBoost, many other algorithms are there. So I have mentioned here only few of them, but today we'll discuss these two. broadly we'll discuss KNN and logistic regression. So let's start. What is KNN? So basically, KNN, the full form is K nearest neighbor. So K nearest neighbor is a non-parametric machine learning model or algorithm. So you see here I am writing non-parametric. Non-parametric means there is no parameter to learn. Generally, in today's world, whatever DL algorithms we use or DL methods we use, all are parametric. That means we have to learn the parameter. When we say that we are training a model, we are doing nothing. Rather, we have a family of function. For that function, what are the coefficients or the parameters that we want to find out? Okay, so here, but this one is not a parametric model. Here we don't have any. Actually, it do not have any function. Rather, we'll use a simple idea of distance measure to find out k nearest neighbors or k number of neighbors from a particular point, and using the output of these k nearest neighbor, we'll decide what will be the output for the current data. Okay, so here it is very easy. KNN algorithm is very easy and simple to implement, and of course, it is a supervised machine learning algorithm. It can be used for both classification and regression. As we are discussing only classifications, we will concentrate on that. And the main idea of KNN that it assumes that the similar things exist in close proximity. That means if you have two class, there are some data belongs to one class and some data belongs to another class. If you got a new data, if it is close to a particular class, that means the data will be belongs to that class. So that means the idea is that those who are same class, they will live together, or they are the distance between them is very small. In other words, similar things are near to each other. Okay, now question is how will get the distance. So there are different distance metrics available. So one distance metric that is very much being used is called Euclidean distance. Euclidean distance, everybody knows how to calculate the Euclidean distance, the formula everybody knows. But still, I'm telling you that this is xi minus yi whole square, summation of I equal to 1 to k. Here, if a data point has k number of components, now for each component, you just subtract and square it, add them and take the root over, which is called Euclidean distance. But there are also other distance measures available which can also be used in KNN. One is called Manhattan distance, another one is called Minkowski distance. So your Euclidean distance measure is a form of Minkowski, where here you see it is same summation I equal to 1 to k xi minus yi whole to the power q whole to the power 1 by q. So here q, if you put q as 2, it will become Euclidean. Okay, so we'll use this distance measure to calculate the proximity, that how much distance that a particular data point is from other data points. Based on that, we'll decide what will be the class. So the algorithm is very simple. What? Now you have a data set. The data set contains your features and their corresponding labels. What you do first, you load the data set. Now, as it is a k nearest neighbor, that k you have to initialize. That means how many neighbors I should consider for finding the actual output of my current data, which is a new data. So that k you have to choose. Okay, so then once you choose the k, next step, that for every example, let's say you got a new data point, the data set already there, existing data set is there, you got a new data point, you do not know what will be its output. Now you have to find out. So we use this algorithm. What we'll do now, for that query data point, we call this new data point as, let's say, query data point or query example. For that query example, you find out the distance of all data points from that query example, even if means whatever data point available in that class or in that data set. So from every data point, you find out the query example. Now once you got the distances, now fourth step, that you sort the distance of these query example to all data point in ascending order, and pick k entries. K, if you say k is 5, that means I want to use 5 nearest neighbors. So first 5 smallest distance data point you collect. Okay, and from that k or 5 data points, what you do, you check what is their label. So if it is a regression problem, then we need a real number, so you calculate the mean of these data points or outputs. And if it is a classification, you take the mode means which class has maximum. So if you put in a diagrammatic form, it will be easier to understand. Now you see First, what you do, we have a data set. The data set, let's say it is a three class classification problem. One class of data point is orange, another one is green, and so another one is yellow. And we got another data point, a new data point, which is here gray. So I don't know what is the class of this data point. So what I'll do, I have to find out that whether this new data point will belongs to this yellow class or green class or this orange class. So once you load the data and you got the new query data point, first step is that you calculate the distance. So here you calculate the distance from every other data point available in that data set, because we know that the data set are there, and for every data there is corresponding output is also there. That means the labels are there like green, orange, and yellow. So here you calculate the distance of this query data point from all other data points available in the data set. Once you got, now what you do, you got all the distances from this query example. Now you sort them in ascending order. So you sort them in ascending order. Let's say this is 2.1, the distance from this data point, and this data point is 2.1, 2.4, 3.1. You just sort them. And let's say I have initialized k as a 3. That means I will take only 3 nearest neighbor to decide what will be the class of this new data point. So here, these are the distances. So I will take 3 as the k is as the 3. So I will take the first 3 distance or first 3 data point. So now when I take the first 3 data point, as it is a classification, so take the mode. So what is the mode? Which color is has a maximum number? So here this yellow has a maximum number because there is 2 yellow and 1 green in first 3. So if I take k as a 3, so I will get the number of votes. I can say it can like a maximum vote. So the maximum vote for yellow is 2 and this green is only 1. So the new data point, what we want to assign, the which class will assign this yellow. Okay, so this is the way it is being done. So in practice, if you want to apply this one, so directly in sklearn there is a means library functions available. You can directly use it. We will discuss today how we will use that. So, but there is a twist that if you increase k, sometimes the output will change. Now you see here, there are two classes. Class B, which is your green, class A is red. Okay, now this is my query data point. This question mark is my query data point or new data point for which I want to decide what will be its class. Now, if you see the distance, these are the distances of all the data point. If I take k as a 3, so this is my 3 area. Within this circle, there are 3 data points available. And for these 3 data points, now these 2 are green and 1 is red. So I will assign the maximum number of values, which is 2, that is green. So this will be green. Okay, but if you take k as 7, so k as 7 means all these data point again will come. Now when all these data point will come, then you see in this case the red or class A has a maximum values, that is 4 number of red and 3 number of green. So when you take k as 7, now suddenly the class of this new data point will become red. It's not green. So that you remember that the value of k is basically a factor of deciding what will be the output. You will judiciously choose what will be k. There is no thumb rule. You have to choose it. Okay. So this is called the KNN or k nearest neighbor. Very simple algorithm. And it is a non-parameter because you don't have any parameter. Now let's see another algorithm that is called logistic regression. That also will be using this algorithm in our NLP. So that's why I kept it here. So what is logistic regression? Even if it is C, you see here it is regression is written, but it is not a regression. It is used for classification. Why we call it as logistic regression and when we will use it? The logistic regression is basically a regression analysis like the linear regression analysis for regression task, and which is basically used on a binary classification problem. But I will show you that it can also be used for multiple class classification problem. That is no problem. There are algorithms available for that. Just a simple tweak. But actually, you have to understand what is logistic regression. Now, the logistic regression is basically it is a predictive analysis which will predict the output probability for a particular input. It is not going to give you a real number. like the regression, linear regression is giving, it's not going to do that. Rather, it will calculate a probability. So, and why we call it as regression, and why the what is the meaning of logistic, that we'll discuss. So here you see, even if it is regression, what it is classification. Let's see. So here one function we use, that function is called logistic function or sigmoid function. Logistic function is being used or sigmoid function is used. This sigmoid function is this one, gz equal to 1 by 1 plus e to the power minus z. So this function, what it is going to do? Now it is basically, if you plot this function, it is like S-shaped plot. And the maximum value, all the value, whatever z you put, whatever real number you put here instead of z, then the value will be between 0 and 1. It will never touch 0, it will never touch 1, rather very close to it, may be very close to 0, it may be very close to 1, or in between any value. So our probability is nothing but between 0 and 1. So that's why we are using this, so that we can convert the output into a probability value. Okay, but in general regression case, what happens, you see, this is the plotting, and here I am plotting it from -6 to 6 in the x-axis, and you see it is nearly close to 0 and nearly close to 1, it is maximum. Even if you take the infinity here, the z can be infinity, plus infinity or minus infinity, it never becomes 1 or 0, it is very close to that, because there is a 1 here. Okay, so now question is, what z will represent here? Now, in general regression case, what we are using, generally the regression function is nothing but this is y equal to beta 0 plus beta 1 x1 plus beta 2 x2 dot 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 plus beta n xn. That means this is a regression, linear regression equation. So in linear regression, what actually we want to find, that let's say you want to find out the price of a house or a house price prediction. For that, this linear regression formula is being used. That means here we want to find out the values of beta 0, beta 1, beta 2, and beta n. These are the coefficient. Here x1, x2, xn all are called the feature values, because the feature values are given, and you model this as a regression problem. And we know that the class of function for regression is this one, but this is a class of function. That means for different coefficient values, that is beta 0, beta 1, beta 2, and beta n, you will get different actual functions, but there will be one actual function available which can map these x1 to xn to its corresponding output y. So we have to find out that actual function. That actual function means we have to find out these beta values. These beta values are basically called as parameters. So remember, parameters are nothing but these coefficients of these functions. So these beta values are called the parameters. That means during training, what actually we are learning, we are trying to learn these parameter values, or what will be these coefficient values for that function. Okay, similarly, and as it is a regression problem, we are using this function. But for classification, we don't need any real number as the output. For classification, there will be two output. Okay, let's say for true class, I am using as 1, and for false class or negative class, I am using as 0. So there will be two values. But in a real number, real regression case, the y can be any value, any real value. But we don't need. So that's why this function cannot be used in the classification case. Even if we want to use this regression function directly, we cannot use. We need to convert this regression or this equation or the value of this equation into a probability value, that is value between 0 and 1. So for doing that, we are applying this y, this total value, this total equation's value as z in this function. So we are using this sigmoid function or logistic function. So here, actually, what is this? It is 1 by 1 plus e to the power. Instead of minus z, what you write? Minus. Here you write beta 0 plus beta 1 x1 plus beta 2 x2, like this, plus beta n xn. Okay. So that means this regression equation, this is the regression equation, this regression equation is being used in the classification. That's why the name regression comes. Okay, why it is logistic? Because we are putting this regression equation in a logistic equation. This is a logistic equation. That's why the name is logistic. So we call it as logistic regression. Actually, we are using regression, but we need the value must be within 0 and 1, so that we can predict what will be the output. So for that reason we are putting this in a logistic function in this format, and it will reduce, or it will project the actual output here, this regression's output between 0 and 1. Based on the predict probability, you can decide whether it will be 0 true or it will be false. Okay. So that's why it is called a regression. Now, same thing here, it is written that if you have input value x, that is, let's say you have only one feature, okay, and you want to predict something, or one or two feature, what will do? So you will use the capital, here we are using Greek letter beta for representing the parameter or coefficients, and my equation will be like this. This one is my equation. What will be? 1 by 1 plus e to the power, this is minus, I forget to put minus, so it is minus e to the power minus beta 0 plus beta 1 x. Okay, so in this way you can calculate, and the value will be between 0 and 1. Once you have the probability value, now based on the value you can decide whether it will be positive class or negative class. Very simple idea, that if the probability is greater than 0.5, you can say it is a positive class, and if it is less than 0.5, we can say it is negative class. So question is how we learn. So you see, this is beta 0, but the question is how we learn this parameter. This is nothing but model training. In model training or modeling, what we are saying, the algorithm is basically, even if we are using this, the algorithm is nothing but it is a family of function. Family of function means all these functions of the format can be used here. But what is the actual function? That actual function will depend once you find out these coefficient values. Like if it is 3 plus 5x1, so then only we can say that yes, it is the actual function. But if I write only in a general term beta 0 and beta 1, it will not actual function, it is a family function. You replace beta 0 beta 1 with the different values, then you will get different functions. So in that function space, what we have to do, we have to find out the actual function which will map these x or your features to output y. Okay, so how we'll do that? So for learning, we have a method. Very simple idea. This idea is common for everywhere. That is in deep learning also, the idea is same. What we'll do? Now we'll first, we know the function. That function is here 1 by 1 plus e to the power minus beta 0 x beta 0 plus beta 1 x1, like this. This function is there. And we have the input x values are there, and the corresponding y value is also there. Okay, so what we'll do, first we'll initialize the, because you don't know the beta value, we have to find out the beta values. That is called the learning. So what is the procedure? The procedure is very simple, that first you randomly initialize the beta value. So what is my function? So my function is here I am using 1 by 1 plus e to the power, let's say I have only two features. Let's say my data set is, let's take a sample data set, it will be easier to understand. Let's say I have two features and one output. The feature is a BMI of a person and blood pressure. Okay, so blood pressure. So these are the two value, and the classification problem is whether you are diabetic or not. Let's say diabetic or not. So now what you do, I have two features, the values are there. Let's say here the BMI is 3.4, blood pressure is 90, and it is not diabetic. And let's say it is 6.7, the blood pressure is 120, and it is diabetic. Like this, you have many data present in the data set. Okay, these are the features, these two are the features, and this is my output. So what we'll do here, I will try to put this in a logistic regression framework. You remember, every algorithm, whatever the machine learning algorithm is there, every algorithm is associated with a family of function. That means we want that try to fit this type of function on this type of data. So what will be the equation here? The equation will be e to the power minus here this beta 0 plus beta 1. Here x, let's say x is BMI. So into BMI, okay, plus beta 2 into, let's say, BP, blood pressure. Okay, now this is my equation. So here BMI value got, BP value is also there for every data point we have, but we do not know what is beta 0, beta 1 and beta 2. If I got the beta 0, beta 1, beta 2, then it will be easy to then we can say that yes, this is the function which will map in these features to the output. Okay, now how we will get this beta value? So this is my family of, this is the function which is going to be used to find out this beta value or try to map input to output for getting this beta value. What we'll do now, first you initialize the betas, randomly you initialize the beta. Okay, so you put some random value. Let's say I put beta 0 as 3, beta 1 as 2, beta 2 as 5. So now my equation becomes 1 by 1 plus e to the power 3 plus 2 into BMI plus 5 into BP. So I got the function. So when I got the function, I got the exact function. But that exact function may not be the accurate function, because what we have done, we have just randomly put the beta values. But if I use this function and check whether these input will give, when I put this input here in this function, whether it is going to give you 0 or 1, whether it is going to give you or not. So what will do? You just put 3.4 here in BMI and 90 in BP. It will give you one value. Let's say the value is 0.7. Okay, because it will give you a value between 0 and 1. Let's say the value is zero point 0.7. Now the 0.7, we have already taken that if it is greater than 0.5, it is 1. So now that means for this value, for this row, the predicted output is 1. But the actual output is 0. That means there is error. Okay, so first what you do, similarly you put one data point every time and check whether what is the predicted value and what is the actual value. Okay, and initially when you have done that, what will do, the predictions what you got, first you initialize, then make the prediction. Once you got the prediction, then you calculate the error. So this is the important core part of every machine learning and deep learning. How you will model this error. So here, very simple. How will model it? Because if it is a regression problem, it will be easy. But for a classification problem, I will model it. Now I am saying that this is 1, but this is 0. That means it is misclassification. So you count how many misclassifications are there. That is the error. Out of, let's say there are 10 points, for 10 points when I put on this equation which I have randomly initialized, when I put in this equation, I got 5 correct, let's say 3 correct and 7 incorrect. So the error is here 7. Okay, means number of misclassifications are there. So actually once I got this error, then I try to minimize the error. How will you minimize? We need to minimize the error in such a way that by changing the beta values. Because initially I have taken these beta values, but these beta values is giving me error. So I have to change the beta value or update the beta value. So how will update it? There are algorithms available called gradient descent algorithm. Okay, so let's see. So here first you initialize the parameter or these beta values randomly, then you got the function. Now this is your random initialized function. Then you put one value from the data set and take the output as the prediction output, and this prediction is there. You have for each of these prediction output, their corresponding actual output is also there. Now you have to calculate an error. So here the error calculation, in classification case, we use a error calculation formula. We call it as cross entropy formula. Okay, so let's see. So this is the error calculation or cost. What is it? Now, what is the error function here we are using? So the error function is nothing but, for one example, you got the probability or prediction value, the probability value. What you do, minus y into log p plus 1 minus y into log 1 minus p. This one is called cross entropy, binary cross entropy. So this cross entropy is being used to calculate the error. So once I model this error function, my objective is that how can I change the beta value so that this error, overall error, will be minimum. So this is for one example. So for all example, you just sum all the errors and divided by number of data points. So let's say I have m number of data points. So I collect all the errors for each data point, sum them and divide it by m. So we'll get the total error. So this is the total error. Once you got that, what is my objective? So here my objective is that we should change the beta value in such a way so that the error will be minimum. Okay, and to do that, one algorithm is being used, a very famous algorithm that is called gradient descent algorithm. Okay, so here once you calculate the error, overall error you have calculated, then check whether that error is minimum. If it is not minimum, then what you do? You update the beta value, because the initialized beta value what I have done is not correct. So you update it. So for updating, what we'll do? Now for updating, we'll use a gradient descent, and for gradient descent this updation rule is golden rule. You have to remember what is the golden rule. Now what will be the new beta? Now for every beta you have to apply this one. Now beta new is equal to old beta minus alpha, which is called learning rate, into gradient of this cost function or error function. So this is the error function. You calculate the gradient. Gradient here means the derivative. Once you got the derivative value, you multiply with a alpha. Alpha is called learning rate. So that alpha is a hyper parameter that you have to provide. Generally it is very small, between 0.01, 0.001, like this. And beta old is beta old. So you subtract it. Now you got a new beta. So for every beta value, beta 0, beta 1, beta 2, you apply this formula and get the new beta values. Again, when you get the new beta values, you get another new function. The previous function gone, you got another function. Now for that function, again you input all these training data, make prediction. Again you calculate the overall error and check whether that error is minimum. If it is not, again you update the same rule. So this process will continue until the error is minimum. And when the error is minimum, or the number of iteration, we call this as iteration. If the number of iteration reaches a maximum threshold what you have given, then you will stop it. And whatever beta value is there, that beta value is learned from the data, and that will be put in that equation, and you got the final equation. Once you got the final equation, then that will be called your model. Even if you got new data, you just put in that function, it will give you the result. Is it okay? Is there any doubt on this part? Because this is very important. Okay.
Okay, continue. Continue.
So if I put this everything in a more perspective, this is the algorithm, full algorithm. What I have now, I have the input, the training data, that is number of features along with their corresponding y. Okay, so there is a question. What is the meaning by hyperparameter? Now you see, the parameter, what are the parameter? The parameter are the coefficients what we are going to learn from the data, because we are using the data now. Here we have the data, we create a function, then calculate the prediction, then create the error, find out the error, and then update. So this procedure is basically used for getting the values for the parameters, or we call this as training. Training is nothing but to find out the best parameter values for that function, so that the output there will be the mapping from input to output, correct input to output mapping will be done. But hyperparameter is what? Hyperparameter is not going to be learned from the data. There is no algorithm to be used for learning it. What it will do, you have to manually put this. Okay, you try one value and train a machine learning model, or train this, and if you got that it is not going to solve, means not giving good result, then you put another value. So the value which the user will provide during training, we call this as a hyperparameter. Okay, parameters are to be learned from the data using this algorithm, but hyperparameter what the user has to provide. Okay, and here this hyperparameter alpha is basically called learning rate. At what rate you are approaching to the minimum, because this is nothing but what we are doing, we are trying to minimize the error. What is the error? The error is this one, this error function. So for what beta value the error will be minimum, that we have to find out. So it is nothing but a mathematical, if you go to the mathematical part, it is nothing but a optimization problem, that we have to optimize this function so that the overall error will be minimum. How will do that? Now we have to update only the beta. So for what beta values this overall error will be minimum, that we have to find out. So minimization function. So we know that in optimization, to do a minimize, we have to calculate the gradient and use this method. Okay. So this is called, is it clear what is hyperparameter? Okay. Now you see the algorithm. First we have the data set, and we have to set the hyperparameter, that is learning rate. You have to decide initially that what will be my alpha value, 0 0.1, 0 0.01, or like this, and how many iterations I want to perform. Okay, when I say error is minimum, minimum for somebody, minimum can be 0.1, minimum can be 10%, minimum can be 15%. That is up to you, and that is specific to the problem also. So here you just, instead of doing that, what you do, you just fix a maximum iteration, that these steps will go for this number of times. Okay, and once we have given these as input, then you initialize the beta randomly. Let's say here you can initialize 0, randomly initialize any value. Let's say you initialize to 0, all beta value will be 0. Okay, or any small value, and you start the iteration 1, and then what you do, now for every iteration, 2 max iteration means you start from iteration 1, go up to max iteration. What will do, now calculate the prediction, because the beta values already you know, we have initialized, that means we got the function. So we have to put every data point from this xy pair here. You put every x, get the prediction. Now you got, for every data point you got the prediction value. Now you calculate the cost. That means you have the prediction output, you have the actual output from the data set. Use this cost function to calculate the overall cost or error. Okay, now once you calculate it, next, to update, you have to calculate the gradient of this error with respect to every parameter. Now here j is the, let's say call this function is called j. I have to calculate the derivative with respect to j, derivative of j with respect to every parameter. Parameter is beta 0. That means first you calculate one derivative with respect to beta, again another derivative with respect to beta 1, and like this. So we calculate every gradient for every parameter. Once you know the gradient, then you update it. How you will update? Now the new beta will be old beta minus alpha into the gradient for that beta. For that, because there are number of betas present. Each beta plus beta. Once new beta, what you will do? Now you check the convergence, whether after getting the new beta, whether they are means you can take a tolerant factor also to cut the error. Once it is done, then you, if it is converged, then you stop, return all the beta. You will get the equation. If it is no, then you again update again you go and update the number of iteration to 2. Again you retrain or recalculate the predictions using the new beta, and the same procedure will follow. So this process is common to generally everywhere. Okay, now this updation and gradient calculation, we call this as gradient descent method. That means what is gradient? Only 3 lines. Gradient descent, if you want to remember, very simple. What? You calculate the gradient with respect, you calculate the gradient of cost function with respect to parameter, update the parameter using this updation rule, that is new beta or new parameter equal to old parameter minus learning rate into gradient of that parameter, and then you get the new beta, and this process is not called your gradient descent process. Okay, so this is called your logistic regression. Is it clear what is logistic regression, how to train it? How is the hyperparameter? See, it is up to you, it is up to the user to decide the hyperparameter. There is suppose you want to find out what will be the best hyperparameter. There is no such method available to find out the best parameter. You try different hyperparameter values, which will give you the best, that will be the best one. There in your programming, there is grid search that can be used to give a number of hyperparameter at a time, and the training will be done on each hyperparameter, and whatever hyperparameter will best, that will be written, and you use that in future training. Okay, so is it clear? Yes. Okay. Okay. So hyperparameter you have to decide. It is a user's prerogative. But parameter means It is on the data, and the algorithm will decide. Okay. So once you train the model, when I say training a model means finding the values of the hyperparameter, values of the parameter, that is beta value. So once you, that means now somebody will you must have heard that in LLM this is a 175 billion parameter model. 175 billion parameter model means you imagine what will be that function where these many coefficients are there. So, and the learning is done for these these parameters only. That means there are 175 billion betas are there in that function, and your training algorithm is trying to learn these values, and the procedure is similar. That gradient descent is used everywhere. Okay, and we'll also see when we'll discuss deep learning, see how gradient descent will be used there. The variations of gradient descent is there, but the overall idea is this one. Randomly initialize the parameter, calculate the error, take the gradient of that error with respect to the parameter, update the parameter using this rule that nu equal to old minus alpha into gradient. Okay. Now, once you got the parameters, how you will predict? So here one example I have given. Let's say we have to predict whether a person is male or female based on the height. Only one feature is there, that height is given, and you have to predict whether it is male or female. And you have already trained a model because you got the data set of height is male or female, and you have already trained it, and you got the beta value. So here it is B means this beta value. So you got the beta value, that is minus 100, and let's say 0.6. Now one person came, and you got to know that his height is 150. You have to predict whether he or she. What will do? Now you have the model because the beta values are there. So you put these beta values minus 100 and 0.6, and here x is 150. You put it, you got this as the output. Now here it is less than 0.5. So obviously is in probability is near or equal to 0. That means it is a male. Okay, let's say if male is 0 and female is 1, if you have done like that, this is called the prediction. Okay. And how to decide? There is a simple method that if the probability is less than 0.5, then it will be one value. If it is greater than 0.5, then it will be 1. It is 0 or it is 1. One is positive, one is negative. Okay. So this completes your first part of this today's lecture, that is model training and model training. So we have done it. Once a model is trained, next job is to evaluate it. So there are some metrics available, or we call them as performance measures. These performance measures will be used. Okay. The question is, since we use dot fit to train the model, is feeding the loss something that needs to be done separate? No. Here, when we'll discuss, we'll do the hands-on session. Everything is there. We in a traditional way, we don't have to do anything. So automatically, the whatever we have discussed, that is written, and in that function we just pass the values, automatically it will calculate the coefficients. We don't have to do anything else. Okay, that fit is doing that. Okay, we'll discuss. So in evaluation, once a model is now you have to evaluate whether that model is good or bad. So for evaluation, we have already kept a test data set, because if you use the training data set to test whether your model is good or bad, it's of no use. Already these data are already exposed during training. During training, already the model knows that these are the data. Sometimes what happens now, the model will not generalize it, rather it may be remembered that. So in that case, it is not a good idea to use this one. So what we'll do, we'll have the separate test data set. On that test data set, you apply the data on that model, you will get the prediction, you have the actual prediction there, and you calculate. What are the measures? The measures are accuracy, precision, recall, and F1 score. So what is accuracy? Accuracy is called overall correctness. That means if you have 10 data points that is being predicted by your model, and out of them, how many are correctly predicted? So that means accuracy is out of total prediction. How many is accurately predicted, both positive and negative? That is called accuracy. What is precision? Precision is correct positive prediction. That means emails marked as spam are actually spam. how many of them are actually predicted. If we say in another way that if all from all instances of the of that data set, the model predicted as positive, and how many are actually positive. The model will predict something as a positive. Out of these positive, how many are actual positive? Because the model may mispredict something. So what is that percentage? That is called precision. Recall means that ability to find all positive, means out of all correct predictions, all positive predictions, how many of them are correctly recalled or correctly predicted by your model. And your F1 score is the balance between precision and recall. That is a harmonic mean between precision and recall. If you see, we need a confusion matrix to do that. What is a confusion matrix? Confusion matrix is basically a k cross k matrix, where k is the number of classes. If it is a binary class classification problem, then it is a 2 by 2 matrix. And if it is a 2 by 2 matrix, one end it is true class, in another end it is a predicted class. So that means this one is called true positive, means predicted is positive and actually is also it is positive. So it is called true positive. This is false positive. False positive means positive. That means your model is falsely predicting positive for the negative class, actual negative class. So we call them as false positive. This one is false negative. False negative means actually the data is positive, but your model is predicting them as negative. So that means falsely the model is predict them as negative. So we call it as false negative. True negative, actually it is negative. The model is also predicting is negative. So using these four values, we can calculate precision, recall, and your F1 score and accuracy. What are the formulas? So these are the formulas. Your precision is that true positive divided by true positive plus false positive. That means here this is the predicted positive. That means your model is predicting these many are positive. Out of them, there are these values are true, but this many are false positive. False positive means falsely predicted as positive. So out of all positive prediction, how many are actually positive? Out of all positive prediction, how many are actually positive? So this ratio is called precision. Recall is that total number of positive is there. So out of them, how many are actually recalled as a positive? That is TP by TP plus FN. So here TP plus FN means these two values are actual positive, but out of them some are negatively predicted. So for them, the recall means how many positive class has been recalled correctly by the model. Okay, accuracy is you just add the true positive and true negative divided by all prediction, all values. So total correct prediction out of the all prediction. So we call it as accuracy. What is F1 score? F1 score is the harmonic mean of a precision and recall. That is 2 into precision into recall divided by precision plus recall. So sometimes if it is if the data set is a little bit imbalanced, so it is better to report F1 score, because F1 score will have both information of precision and recall. Okay. So this is called model evaluation. There are also other evaluation metrics, but these are the very basic model evaluation metrics that is used for classification. Now, during model evaluation, sometimes you will get two problems. One is called underfitting problem, another one is called overfitting problem. So, in underfitting problem means that the on the training set, the model is not doing well. Means your model has not learned anything during training. Whatever model it is learned, it is not good. It is not predicting well. So, when your training error on the training data, the error is high, we call it as underfitting. Means the model is not doing well. What is overfitting? Overfitting is its counter. That on training data it is performing very well, but on test data set when I apply that model, the error is more. So that is the test error. If it is more, then we call it as overfitting. And this is more challenging, because if it is a underfit, then you can discard the model and create another model. But it is very difficult for a model to discard if it is performing well on training data. Means on training data it is giving perfectly fine, doing well, but on test data it is not doing well. That means the model is not generalized model. Rather, the model remembered the training data. That's why it is performing well on training data set. So in that case, some generalization or regularization techniques available that will be used to overcome this overfitting problem. Okay, so there are the two problems. So once you overcome the overfitting problem, you got a good model. Now the model is ready. What you do, you have to deploy it or you have to use it for newer data's prediction. So what is prediction and deployment? Now, once the model is ready, you got the new data. This is your trained model. You give this new data to the trained model, and the trained model is going to predict it. Or you can deploy it in anywhere, in any platform. Okay. So this is one way to depict it. You see, this is my exact input. You do the pre-processing and you got the prediction. Now you see, when you got a new data, whatever pre-processing already have done before training on the during training time, you have to apply the same pre-processing technique on the new data. Then only you can apply your data to the model, and the model is going to predict. You see, the critical part here is that when you got a new data, you just apply the exact same pre-processing as you are using in training. And once the data is pre-processed, then only that can be fed to the trained model, and the model is going to predict it. Is it okay? Is there any other question? So this completes the whole chapter, basic of ML. I think you must got some idea. Those who do not know, for them, it is a good way
If
to
any doubt,
start.
you can
And
ask.
those
You
who
can
know,
unmute
it is a
yourself and
refresh.
ask if any doubt.
If you have any
Otherwise,
doubt,
I will
please
go for
ask.
the hand chant.
Or otherwise, we will discuss answer.
Okay, Nanshan, you can go for the hand chant.
Okay. Okay. Is it visible?
Yes, yes.
Yes. So today what we'll do,
So I have
we'll
all
use the same
unmuted
Titanic data set.
everyone. If any doubt, you can unmute yourself and can ask. Okay, you can have already
You
unmuted.
can ask during this also. You can ask. Okay. So today what we'll do, in the last class we have seen how to pre-process the Titanic data set. Okay, and we have discussed all pre-processing techniques there by taking the example of Titanic. But here what I'll do, I will use only those pre-processing techniques which is required for here, and then we'll apply these four models. I have discussed KNN and logistic regression, but still I will show you SVM and discent in the same way we can apply, because these are abstract thing. The detail did not know to be known, because there is APIs available or the functions available. You can just use them. Okay, so let's start. First, to do that same, you have to import all the necessary libraries like pandas, numpy, cburn, then from sklearn. As we are using sklearn, because here heavily we are going to use sklearn. So in scikit-learn, under the model prediction, there is a train test split function. So this train test split function is going to split the data set into training and testing. Okay, that we'll see. And in the scikit-learn's pre-processing submodule, what we have, all pre-processing functions what is required, like label encoder, standard encoder, standard scalar, one-hot encoder, min max scalar. All these pre-processing methods are there. You just whatever is required, you just import them and you can use it. And similarly, for applying the models, there are different models available. Like if I want to apply KNN, so the name of the function here is K neighbor classifier, which is present on scikit-learn's neighbor module. Similarly, if you want to use logistic regression, so the name of the function is logistic regression. Here L is capital, R is capital. It is present in scikit-learn's linear model category or submodule. And for SBM, it is present under the SBM subcategory is called as SVC. Okay. And for decision tree classifier, it is present on the tree. So we just import everything. And for calculating the accuracy, precision, recall, here we the submodule is matrix. Under the matrix, we have accuracy score, confusion matrix, classification report, precision recall is also there. You can also import them. So once you have imported them, next is load the data set. So the data set already there in the C-buns. That's why it is easy to load it. Just you call sns.load underscore data set Titanic. So it will load the data set. Now you see this is my data set. So we'll do the simple EDA, not all the techniques, whatever is required. So first we have to understand how many data points are there, how many are them are null values, non-null values. So for that, what we'll do, you just print the df info. So here the shape says that 891 rows are there, 15 columns are there, and these are the name of the column. They are data type. Already we have discussed in the last class. So from this, it is clear that there are some features which has missing values. Okay, and to find out how many missing values are there, you just call df.isNull.sum. So you'll see age has 177 missing value, embarked 2, deck 688, and alive 0. Okay. So these are the missing values. So if you just remove all the zeros, these are only the missing values. Now, next step is that do we need to drop some columns? Because if you see, if the columns are already there, it means let's say there are some duplicate columns or same information present in more than one column. So we can drop one. So you see here, this is my total number of columns. Just see, this is my total number of columns. Survived, P class, sex, age, SIBSP, park, etc. Now you see there is one column called alive. Alive and survive. Actually both are same. Here survived is in binary format 0, 1, and in alive it is no, yes, like this. So both are same. So why we should keep both? Let's drop one. So we can drop it. So how will drop it? So to drop a column, very simple function I have already discussed in the last class, that drop function. So df.drop, give the name of the column. So the name of the column I want to drop is alive. So just write alive within single quotation. Axis equal to 1 because I want to drop from the column. The column is 1, row is 0. So you just drop it, and if you see, execute it, now the alive column is not here. Okay, that means now I have 891 rows and 14 columns. Before there was 15, now it becomes 14. Now let's do the missing value handling. What I'll do, so here there are 3 places which has missing values. One is age, another one is embarked, another one is deck, another is embarked town. Okay, so 4 places actually. So what we'll do now, age, we cannot remove age because age has how missing values, 177 out of 891. So instead of removing those rows which has age value, age is missing, because if you remove 177 rows is going to be wiped out. So what we'll do, we'll impute them by using a mean, because it is a numeric feature. So mean or median, whatever you can use. So here I have used mean. So I will do that. Now df.age, you just select the age, dot fill na. Fill na function will do what? Now wherever there is a missing value, then it will be used to fill it. What to fill? Now calculate df age dot mean. On that column, you calculate the mean. Whatever mean value will be there, that will be used to fill all the missing value in the age column. So now you got the new df age. Now similarly, for embarked is a categorical column from which place the journey started. So it is a categorical column. So how to remove, impute that? We can use mode. So here same thing. Yes. Is there any question? Yes. Oh, somebody is talking.
Yes, Vichitra, any doubt?
School bila.
Okay. So let's see how to do that. I just create the mode and calculate the mode on the embarked, and then fill the missing value for that embarked column. Now, another technique we can say, we have already discussed, that if any column contains more than 50% missing value, just drop that column. So here you see, for this one, deck, there are 688 positions in that deck column are missing. So we cannot delete the 688 rows. Rather, we can delete the column. So as it is more than 50%. So what I'll do? So just drop it same way by using drop function, df.drop, pass the deck, axis equal to 1, in place is true, so it will be dropped. Okay, now once you apply all these things, then what you will see? You will see that there is no missing value present. And for embarked town, there are two places in the embarked town which has missing value. So what I have done, I have used drop NA. Drop NA means it will drop the row. So these two row we have removed. So we have done everything. That for age we replace the age by mean, and for embarked we replace the embarked by mode, and for embarked town we remove the rows, and for deck as it is more than 60%, 50% value is missing, so we drop that column. So now once we have done that, now if you see how many missing values are there, there is no missing value. And if you see this shape, now it is previously it was 891, now it becomes 889, because the two rows we have replaced or dropped by using this drop NA function. Okay, now my missing value problem has been solved. Next, check for duplicates. So how to check for duplicates? So the function is here just df dot duplicate function. So you apply that df dot duplicate function within the df. Now it will give you how many duplicate rows are there. Once you got the duplicate rows, what you will do? You just drop them. So for dropping duplicate rows, the function is drop underscore duplicates. So you just apply this. So what will happen? Now you see there are 111 rows that have same values, and these are some we have present here. So now you have to drop them. So once you drop them, after dropping, you will get 778 rows and 13 columns, because previously one column again we have dropped. Initially we have dropped alive, so it becomes 14. Now we have dropped deck, now it becomes 13. So there are 778 rows and 13 columns. So this duplicate problem has also now solved. Now once these two things are solved, then we have to encode them. If there is, means all the features should be converted into numeric form. So for that we have encode. So encode the categorical variables. So first identify what are the categorical variables. So here this one will find out the categorical variable using this exclude np.number. So what we'll do, when you execute, you will see these are the categorical column names like sex, embarked, class, who, adult male, embarked town, and LM. Okay, now uh, what we'll do, we'll just try to do some encoding. So there are two ways I have told you. One is one hot encoder, another is label encoder. So one hot encoder will be used when the data are basically not means nominal data. If it is ordinal, so if it is nominal, you can use your one hot encoder. If it is ordinal, you can use label encoder. So you see here sex. So I just represent sex as a label encoder. Once a label encoder has been created, then you just do le.fit transform, pass the sex. Okay. So what you will do? The sex column previously it was male female. Now it becomes 101 like this. Similarly, embarked. Now it will also do the same encoding, so it will be converted into numeric. So all these are converted into. So this nominal data, actually, sorry, I have told you differently. The nominal data will be converted by using label encoder. Ordinal data will be used for one hot encoding. So nominal data, these are nominal data. There is no inherent ordering between them. Now come to the class. So there is only one um, column which has ordinal data. Okay, that means first, second, third. So we can encode it using one hot encoder. So for that, what I have done, I have initialized the one hot encoder function, then apply the feed transform under that class. So it will be converted into one hot encoder. So one hot encoder is doing what? Instead of one class, it will be creating three classes. Okay, so let's see. This is your level encoder. This is one hot encoder, and when I apply, you see you will got three classes. Previously it was a class, and now it is class first, class second, class third. I have already discussed what is one hot encoder is doing. So and during that process, what I have done, I concatenated these three and dropped the original class. So the class column has been dropped by using this method, and I have added concatenated these three. Okay. So this is for features. Now for labels. If the label is not in numeric form, that need to be converted into numeric. Here, fortunately, we have numeric column, because the survived column that we are going to use as the as the target or y. So if it is not, then you can also use label encoder for encoding the output column. If it is not in numeric form, you can do that using same format. So once you have done everything, now you will see I got 778 rows and 15 columns. Why 15 columns? Previously it was 3, 13. We have added 3 and removed 1. So it will become 15. Okay. Now, once this is done, next is segregate. Feature put in X, target put in Y. So all feature will be put in X variable, all target will put in Y variable. So here survived is our target. So from the df I just drop survived in survived column. What rest is remaining is your feature I am assigning into X, and I just select df survived, that column, one column, and I am assigning into Y. So X contains the feature columns and their values, Y contains the target column and their value. Okay, once it is done, next you scale them, because every data should be within a certain range. So scaling is required. So for scaling, I have used here standard scalar. So you create the standard scalar function. Now once the standard scalar function is executed, a scalar object is created. Now use that scalar to fit transform the X, means the input feature, you just transform them. So every value present in all the columns of the X or the features will be converted into between a certain range. Okay, so that will be there. What is done? Oh, this one I have not executed. Okay, so once it is done, now every pre-processing activity is completed. We have removed, we have deal with missing value, we have deal with outlier, sorry, your outliers, duplicate values, everything we have done. Now here comes first step before training, that you split them into train and test. So for that, a function is there in scikit-learn called train underscore test underscore split. You pass the feature X, pass the output Y, then what will be the test size you mention. Here I am writing 0.2. That means out of the total XY, 20% will be used for testing, because this is test size, and 70-80% will be used for training. Okay, so automatically it will split. This function will automatically it will split them and create 4 values or 4 variables. One is xtrain, another one is xtest, ytrain, and ytest. And here you see there is a random state equal to 42, because if you do not give this random state value, any number you can put here. 42 general everybody puts, so that's why we have already put that. You can put any number. That means this train test split will actually randomly take 20% and 80% to split it. But if you want to fix that randomness, you have to put this number, so that every time when you execute this one, same value will be in train, same value will be in test. When the train test split is completed, next we have to apply the models. So one by one, one model I have applied. Now for k nearest neighbor, already we have imported the k nearest k neighbor classifier. You just call the k nearest neighbor classifier and passed how many k value or how many neighbors. So n neighbor I am passed here 5. So now this one will be initialized. This is called knn. Once it is done, now you call knn.fit and pass the xtrain, means training feature, and the corresponding output of the training feature. Now what actually it is doing? It is actually training. So the training process, all the steps what we have discussed is done here. And once the training is completed, now the model is ready, and that model is called knn model. So because the variable I have taken here is knn, so here the knn can be used. Knn dot predict, you pass the x test, because you have separately you have separate test data, so just pass that and you will get the prediction on that test data. And the actual test output is present in y underscore test, and the predicted output is here for knn, it is knn underscore pred. Okay, now these two can be used to find out the performance using the evaluation metrics. That will do. Similarly, logistic regression, same process. The just you initialize the function, logistic regression function, and assign a variable, then you fit that on the train and x train and y train, and all the activity will be done there, and the parameter will be calculated, everything will be calculated, the model is trained. Now you got a trained model in LR. Once you got the trained model, now you just predict using lr.predict, pass the X test. So the test data what is there is passed, and it is giving you prediction values. So this is called LR prediction. So the actual output is there in Y test. Okay. Similarly, for support vector machine, same procedure is same. Just call the SBC function and fit it on the X train and Y train. Then you predict on the X test. Okay. So let me run these things. Let me run it. Okay. Now the SBM the SBM model is ready. Okay. Similarly, for decision tree classifier is there. You just call them, and here also pass the random state 42. You can give any number, and I am putting a DT. So your DT dot fit. That means I am calling the fit method. Fit method is basically training. So I am passing the X train and corresponding Y train. It will train it, and once the model is trained, I call the predict method, pass the test data, and it will give me the prediction on that test data. Okay. Now I have the prediction for all four models. And for KNN model, the prediction is present in KNN underscore pred. And for logistic regression, the prediction is present in LR underscore pred. And the support vector prediction is present in SBM underscore pred. Now you got the prediction. Now what I have to do? I have to evaluate what is the precision, recall, and accuracy, and F1 score if possible. Okay, so here I have just mentioned accuracy, confusion matrix, and classification report because everything is there in the classification report. So I have created a function for that called evaluate model. It will take actual data, that is Y test, and predicted data and the name of the model. Okay, and it will calculate accuracy score. The function is there, just call the accuracy score, pass the Y test, pass the prediction. So on that prediction and Y test, it will calculate what is the precision, recall, everything. Similarly, for confusion matrix, just call the confusion matrix function, pass the Y test, pass the Y pred. Okay, it will calculate the confusion matrix for that model. Similarly, classification report, pass the Y test, pass the Y pred. So this function is ready. Once the function is ready, now you call the function. So first evaluate model function is called. I am passing the original output, that is Y test. I am passing the KNN pred output, and I am passing KNN. So what it will do? It will calculate all these three metrics, that is accuracy, confusion matrix, and classification report on KNN model using KNN's prediction. Similarly, for logistic regression, again I call the function, pass the LR pred and Y test. So it will calculate on logistic regression. All these three, accuracy, confusion matrix, and classification. So here you see, just see for KNN, you got the accuracy because this is for first one, KNN. So for KNN, you got the accuracy as 0.77, means 77%. And this is your confusion matrix. So 82, 9, 26, 39. Okay, that means 82 is true positive, 39 is true negative, 9 is false positive, 26 is false negative. Okay, and based on that, this is your classification report. In classification report, the precision is there, recall is there, F1 score is there, everything is there. Okay, and from this, the average, the accuracy is weighted average accuracy is this one, and macro average accuracy is this one. So these are all classification reports and values. Similarly, for logistic regression, it is again giving 0.77, and this is the confusion matrix. And for classification report, this is the classification report. Similarly, for SBM, it is a little bit better, that is 78%. Okay, and this is the precision, recall, everything else here. Similarly, for decision tree, it is 75. So among all these four models on this data set, SBM is performing better. Okay. So if you compare it, put in a nice tabular form, create a data frame on that model, KNN, this is a logistic regression, SBM, I have just put that in a tabular form so that nicely there is a comparison. KNN, it is 77%, logistic regression 77.56, same, SBM 78, decision tree 75. Okay. Now, if you got a new data, now the model is ready. If you got a new data, what you will do? Just let's take from the text data set. I'm taking one example. X test 0. I'm taking only one example. Let's call it as new passenger. and I'm calling the linear, logistic regression. So LR.predict, pass the data, and you will get the prediction. So if the prediction is 0 or 1, that will decide whether it is survived or not. So for that, I have written one if else function, as if else program. So it is giving survived. Okay. So these are the simple way you can apply this one. These are the assignments you will try. Okay, and also I will give you three, four data set in the same manner. You just apply all these models, find out which model is good. Okay, so here this you just all try. Use only these features. So what we have done in our discussion, we have used all features to find out the model performance. But if you see, just see, if you only select these features instead of all, what will be the performance of the model? Okay, this is one part. But for production level, to apply or to deployment for deploying the model, what we need another method called pipeline method, because everything should be put in a pipeline. So in scikit-learn, there is a method called pipeline. So that pipeline method can be used to put everything in a concise form, so that for a new data, we don't have to means apply the pre-processing step by step what we have already done in the training. So everything will put in a pipeline. So this is the job of this one. So here you just import sklearn.pipeline and all other things are there. So this is a simple version of that. So first you load the data set. Then I have selected only these features instead of all features, only selected these features. Then you just create, just drop this one, means just create X and Y axis, sorry, X features and Y is your output. Then calculate the numerical and categorical features. On numerical features, just apply the pipeline. What in that pipeline, what we are doing, we are imputing and means imputer, simple scalar imputer is used and standard scalar is used. So simple imputer and standard scalar, these two has been used. Similarly, for categorical processing, again we are using a pipeline, and two things we have applied. One is simple imputer on the categorical data, as well as one-hot encoder on the categorical data. Okay, so directly all these pre-processing will be put in the pipeline. And now these two things are combined to called as pre-processor. So that is called transformers are this numeric and categorical. These two transformers here we have applied. Means all these two pre-processing is combined into one pre-processor. Okay. Now the model is there. So for model also we have created a pipeline that will collect when before applying the model, it will do the pre-processing. Then it will apply the classifier. So here pre-processing is nothing but the pre-processor what we have created here. This pre-processor we applied here, and for classifier, logistic regression classifier has been applied. So then we segregate the data, train and test using same train test split function. Now we call the pipeline model dot fit, pass this extend, and because this pipeline model has been created, you just fit it on extend and iterate. When you pass all these first on this extend, the pre-processing will be applied, then classification will be applied. Okay, and the pipeline prediction is also same. Just you got the predict model is ready, means you just call the predict function, pass the X test, it will give you the prediction, and this is the accuracy. So when you run, everything is in a pipeline mode, so that when a new data came, you don't have to categorically pre-process it. Just call the function, automatically it will do. So here you see you got a new data, new passenger. What you do? Just pipeline model dot predict. You don't have to pre-process them. So directly it will give you whether it is survived or not survived. Okay. So this much from my end. Is there any question? And just try all these questions what I have made here. I will also give you 3 data set in the WhatsApp group, so that 3 or 4 data set, so that you can small data set, so that you can apply all these techniques what we have discussed. Is there any question?
Yes, any questions? You can. Some questions are in chat box. You can see.
Okay. Can you elaborate the confusion matrix? Okay. Confusion matrix. See, confusion matrix is a K by K matrix. What it is saying, that the matrix is basically used to capture the outputs of the classification model. That means how many are correctly predicted, How many are mispredicted? Mispredicted is a type 1 error or type 2 error, that is false, whether it is false positive or false negative. Once I got all these information, then this information can be used to calculate the metric like precision, recall, and accuracy, as well as F1 score also. Is it okay? Another question is the result of a score and the accuracy in the classification report same. Yes, which score? Just let me see. This one, accuracy. Where is score? There is no score. Which score you are talking? Hmm?
You can unmute yourself. You can ask. But this
Because we
one,
have accuracy score function is there. The accuracy score function is giving you the accuracy. Okay. Any other question? What is support in classification? Support means how many data point has been used to find out that result. You see here, support is 91. That means 91 rows have a class 0 and 65 rows have a class 1. So in deciding these values, this is the number of rows or data points used. Okay, here also 156 data points has been used to calculate the accuracy. Okay, so these are the support means number of data points is being used for calculation. Other question? Accuracy score, yes, this accuracy score is same thing. Yes, I think I have answered all questions. Is there any other question anyone has?
otherwise you can in group also you can ask later. Okay. I think exactly 8:30 you can stop here.
Okay, thank you.